Hi class, and welcome to Unit 3.4, the section about density. And so when we're thinking about density, I have a question for you guys. Have you ever been asked, what's heavier, a pound of lead or a pound of feathers? So without thinking right away, you might want to jump and say lead. But a pound of lead is going to equal the same as a pound of feathers. So the concept that they're trying to trick you to think about is density. We know that lead is going to be denser than feathers. It's going to take a lot more feather to get to 1 pound versus the visual volume of lead is going to be a lot less. And so we will be talking about density for today. And so let's first define density. And so we can define it simply as the ratio of the mass of an object to its volume. And so we can give this an equation. And so what that equation is going to look like is density is equal to mass divided by volume. And so another way people remember this is that if you just give the first letter to each, so D is equal to M over V. The M over V makes kind of a heart here. And so that's a way to remember that mass is over volume because we love density. And so this equation, it can take multiple forms, meaning that yes, density is equal to mass over volume, but you can also say mass is equal to density times volume, or that volume is equal to mass over density. And so when we are thinking about density, what kind of property is it? Is it an intensive or an extensive property? Those terms should be in your brain from last unit. So remember, intensive is identifying. So density is an intensive property because our identifying properties, they depend only on the composition, not the amount. So that's a little review from last unit. And so the only other thing I want to note about the concept of density itself before we get into some calculation problems is that it does have a relationship with temperature. And so typically, as temperature increases, the density of this object is going to decrease. Would this be an indirect or direct relationship? You guys should have said indirect. So as one variable goes up and the other goes down, that is defined as an indirect relationship. So for example, I think it's easier to see on a graph. If we have temp on the bottom and density as our y-axis, as we increase our temp, we're going to see a decrease in density. So it'll look something like this. This is what an indirect relationship looks like on a graph. And so let's start with some example problems to calculate density. So the first question is, or example problem is saying a copper penny has a mass of 3.1 grams and a volume of 0.35 centimeters cubed. What is the density of copper? And so we first have to remember that our density is equal to mass over volume. So if we plug in 3.1 grams, recognizing that's our mass, because grams is the unit of mass, dividing it by 0.35 centimeters cubed, or our volume, we then would get 8.8571 grams per centimeters cubed. Now, Is this multiplication or division that we're doing in this process? Sorry, it is division. But remember the rules for sig figs. Multiplication and division is dependent on the number of sig figs. Well, luckily for us, both of these only have 2 sig figs, but that means we have to report our answer in 2 sig figs. If that's the case, we start from the left and we count spaces, 1, 2, and so that means we have to round to this place, and we are looking to the number to the right, which is 5, which makes us round up. So our rounded answer is going to be 8.9 grams per centimeters cubed. Okay. The next problem. A student finds a shiny piece of metal she thinks is aluminum. In the lab, she determines the metal has a volume of 245 mils and a mass of 653 grams. Calculate the density. So again, density is equal to mass over volume. So we put our unit of mass, grams, on the top and divide that by our unit of volume. And then this gives us I think it's 6.6. Let me double check though here. One moment. So 653 divided by 245. Yes, okay, 2.665. In our case, we have 3 sig figs, so how we would round that would be 2.67 grams per mil. Now, is the metal aluminum? So if you remember from the table from your lab, you had the density of aluminum on there. Otherwise, it's in your book. Aluminum's known density is 2.70 grams per mil. So, is it aluminum? Yes, I would say it's close enough to be considered aluminum. Now, what is the percent error? So this is a review of the percent error equation. So remember, we have our experimental value minus our actual or true value divided by our actual times it by 100. And don't forget, we take the absolute value here. So if we have 2.67 minus 2.70 divided by 2.70, don't forget to take the absolute value of the top, multiply it by 100. I will do that on my calculator right now, and you can do that along with me. That gives us 1.11%. So just a refresher, because these knowing how to do percent error will be helpful for lab. Okay. And so we can also use density to find the volume of something. So density is something that we can look up for a ton of materials that are common. Just like how I knew the density of aluminum. So common materials all have a determined density that is reliable. And so in our case, we can use that to find the volume or mass of an object. So let's focus on finding the volume. So how could we find the volume using density? So if we think of that equation again, density is equal to mass over volume. We could solve for the variable v. We could solve for volume. In that case, if we rearrange the equation, we would have volume is equal to mass over density. And now, do we have a mass? 14 grams. Sure do. And we can look up the density of silver. So volume would be equal to 14 grams divided by, and if I look up the density of silver, looks like I don't have that handy, I don't think. One moment, I will Google it. that is 10.5 grams per centimeters cubed. Which, if we do the calculation, then we get 14 divided by 10.5, which gives us 1.3 centimeters cubed. All right, let's do another one. Let's determine the volume of boron if we have, oops, I accidentally put that as grams per centimeter. This should say, I'll have this fixed for you guys' sheets, but just grams here. If we have 14.8 grams. And so we'd have to look up the density. So the density of boron is equal to 2.34 grams per mil. So if we have 14.8 grams, how much volume do we have, or how many mils? So remember, we rearrange that equation as volume is equal to mass over density. And so our volume is equal to 14.8 divided by 2.34. So grams per mil. Which gives us 6.32 milliliters. So now what I have for the rest of the sheet are some practice problems. So what I want you to do is try these problems on your own while I'm around to help you out. So we're going to get lots of practice with density, but there may be a few questions on here that are going to require unit conversions, because again, unit conversions are not going away. So please ask any questions if you have any.